So this next video will cover sections 4.1, 4.2, and 4.3. And so for today, dealing mostly in terms of maximums and minimums. So in terms of absolute max or absolute min, okay, we would have that if f of c is greater than or equal to f of x, or f of c is less than or equal to f of x. Okay. And f of c means at some critical value, critical x value for c. Okay. Is what that is. So to think in terms of a graph, so we look at in terms of a graph of a curve. So something looks like that, for example. We have 2 points. An A here, we have B there. Well, if I look on this curve, we have at this point on the curve where we reach what is called a relative max. It's not the highest value the function takes on because somewhere way up here it goes a lot bigger. But over a short range of x values, it's the highest value my function takes on. And then we also have here, we have a relative min. It's the lowest value my function takes on. But again, it's not the lowest because if you think that that goes on forever that way, then it'll have a smaller value. So you get in terms of Fermat's theorem, which states if f has a local max or min at C, if the derivative evaluated C is equal to 0. So if I look in terms of my graph here again, we can see that if I took the derivative at that point, my derivative is 0. And the same thing here at my min, that derivative would also be 0. Right? So we have in terms of that. Right? So for what is called the closed interval method, we have the following. So we want to find the absolute max or min or min for a continuous function. Function on a closed interval from A to B. And this will be true if what we're going to do is we're going to find the values of that. The critical numbers, A and B. So we're going to just evaluate our function at those two values, right, for one step. The second step is we'll find the values at the endpoint. Clarify this first step up here. Basically, when we want to find the values of f at the critical numbers in between A and B, we're actually basically here, we're talking about the derivative. Get to that. And then step 3, we get that the largest of steps 1 and 2 is the absolute max. And then the smallest of those 2 steps is the absolute min. Absolute min. Okay. So let's go through an example as to how this works. All right. And so we'll do this problem. Find the absolute max of min. Find the absolute max and min for the following. We got f of x equals x cubed minus 3x squared plus 1. And we want to do this on the interval of minus 1/2 up to 4. Right? Which means basically then that this is the A and then this is the B. Okay? So first off, I noticed that for any number I plug in the range from -1/2 to 4, my function is continuous. No matter what number I plug in here, I will get a value. So it passes that first test that it is continuous. So f of x is continuous. That's on the interval. Right? So the next step then is to find our derivative. So f prime x is going to be 3x squared minus 6x. We then want to take our derivative and we are going to set it equal to 0. So we have 3x squared minus 6x equals 0. And we want to solve this for x. Now I notice here that x I can take out of 3x. And we get x minus 2. Which means that either 3x equals 0 or x minus 2 equals 0. So this will give me x equals 0. And then here we would add 2, and we get x equals 2. So my critical values are 0 and 2. Okay? So those are the critical numbers. And now we want to evaluate. So f of 0. So this would be 0 cubed minus 3 times 0 squared plus 1, which will just give us 1. And then f of 2 would be 2 cubed minus 3 times 2 squared plus 1, which will be 2. Or sorry, not 2, negative 3. That's the wrong line. And that'll give us negative 3. Okay? So now we go to the next step, which is evaluate the function at the endpoint. So at the endpoint, so my A and B values, so f of -1/2, well, that would be -1/2 cubed minus 3 times -1/2 squared plus 1, and that'll give us an 8. And then we do it for the f of 4. And so we get 4 cubed, 3 times 4 squared, plus 1, and that'll give us 17. So now the last step says, okay, whatever is the bigger number is the max. So the absolute max then over the interval will be at f of 4, which was 17. And then the absolute min will be at f of 2, and that had a value of -3. So we got it in terms of the absolute max and mins over a closed interval. So section 4.2 then deals with another theorem. And so we have, so let f be a function and then you have that f is continuous on the closed interval. A and B. Right. Part 2, f is differentiable on the interval. So I can take the derivative of it. Right. And step 3 is that f of A equals f of B. Right. And then if all these are true, then there is a number C. So a critical value in A and B in the interval such that f prime, the derivative is equal to 0. Okay? So let's go through an example of how this works. So let's look at this problem. Right? So f of x is equal to 5 minus 12x plus 3x squared, and my interval is from 1 to 3. So first off, again, it is continuous on the interval. I can plug in all those numbers, and I get a value. So we're fine there. What happens at the endpoints? Well, f of 1 would be 5 minus 12 times 1 plus 3 times 1 squared. And that'll give us -4. And if I do f of 3, we get 5 minus 12 times 3 plus 3 times 3 squared. And that also gives us -4. So that's also true. Okay? So it's continuous. The value is the same at each of the endpoints on my interval. And so now we get to the next step, which is the derivative. So the derivative here is going to be minus 12 plus 6x. And so we can take that and set it equal to 0. And so we get, solving this for x, we'll get that 6x is going to equal 12, and x is going to equal 2, and we find out that that number does fall within my interval of 1 to 3. So the last section for today basically puts all this stuff together, and you get in terms of the first and second derivative test. So again, let's look at a graph of a curve. So we have a curve going something like this. And if I look at this, here my function is increasing. So my derivative here will be positive. So my derivative there is positive. Here my function is decreasing. And so here my derivative is going to be negative. And then here it's increasing again. and so my derivative is going to be positive. Okay? We have here at this max, my derivative is going to equal 0, and we have here at a min that the derivative is going to equal 0. So my first derivative tells me what's going on with the slope of my curve. So if derivative is positive, it's increasing. Derivative is negative, it's decreasing. If there's a sign change from positive to negative, we're going to be at a max. And then if there's a sign change from negative to positive, we're going to be at a min. The other thing here in terms of, so that's what we get from the first derivative test. The second derivative test tells me something about the curve. Right? And so let's draw this again without all the other stuff in there. And let's just look at the shape of the curve. So my curve again looks something like this. Okay. This shape is called concave down. And then this shape is called concave up. And then somewhere in here was that point where we made that transition from one to the other. And this is called the inflection point. So for concave down, we have that the second derivative will be negative. And for concave up, the second derivative will be positive. Right? So let's look at an example in terms of how this works. So for example, so f of x is equal to x cubed over 3, 5x squared over 2, plus 6x plus 7. So first derivative test, we take our first derivative, f prime. Well, this will be x squared plus 5x plus 6. Right? Next step we want to do is take that derivative and set it equal to 0. So we take our derivative and we set it equal to 0. And now we want to solve for x. Well, that quadratic is factorable. We get x plus 3, x plus 2. So that means either x plus 3 equals 0, or x plus 2 is equal to 0. This will give us x equals negative 3, and this will give us x equals negative 2. Okay? So now we make a chart. Okay? So we barely make a chart. We got our number line, and we're going to put these numbers on there like a number line. So this is negative 3. This is negative 2. My terms were x plus 3, x plus 2, and then my derivative. So now, if x is a number less than negative 3, so it helps pick a number. Let's say negative 10. Well, if I plug in negative 10 in here, this will be negative. That'll be negative. And a negative times a negative is a positive. Okay? Now we go between negative 3 and negative 2. Well, this will be positive. This will be negative. And a positive times a negative is a negative. And now lastly, number greater than negative 2. Everything here now will be positive. So if the slope is positive, here we are increasing, here we're decreasing, and then here we're increasing. Right? Here we go from a positive to a negative slope. That means that this is a max. And here we go from negative to positive, which means that this is a min. And then if we take those two x numbers and we plug them into the original equation, we can get the corresponding y values for those 2 points. Okay? So that's what we get out of the first derivative test. So now let's go to the second derivative. Okay? So let's rewrite our first derivative, which we said was x squared plus 5x plus 6. So now we want to find the second derivative, which which will be 2x plus 5. And again, we want to set that equal to 0. And so 2x is going to equal minus 5, so x is going to equal minus 5 halves. Right? And so now we want to do another table. And so we're going to have a table. We only have one number this time, minus 5 halves. Only one term this time, which was this. And then my second derivative. So if x is less than negative 5 halves, this is negative, which means my derivative was negative. And if we're greater than 5 and negative 5 halves, this will be positive, and my second derivative is positive. So this will be concave down. This will be concave up. And this will be an inflection point. So we know something about the shape of our curve. So if I look at this, I can now quickly come up with a rough graph of this. Right? So let's do a quick graph here of my equation. Again, let's write the original equation, which was this. X cubed over 3, 5x squared over 2, 6x plus 7. So let's write down some of the stuff we do know. We know that we want, in terms of points, we know that also, very quickly, we know that the y-intercept is 7. So all I got to do is just put zeros in for x. So I know I'm there. Okay. We know that the values were negative 3 and negative 2. Okay. And so we could come up with values here. And so f of negative 3 is negative 3 cubed over 3, 5 times negative 3 squared over 2, 6 times negative 3 plus 7. Negative 3 cubed is negative 27. This will be a minus 9. That's going to be 9 times 5, 45 over 2. So 22.5. This is a negative 18 plus 7. Let's see, minus 27 and 29. So this is about 2.5 for that one. And then if we do f of negative 2, we get negative 2 cubed over 3, 5 times negative 2 squared over 2, 6 times a minus 2 plus 7. So this is going to be a minus 8/3, so a minus 2.67 roughly. 4 times 5 is 20 over 2 is 10. Minus 12 plus 7. And let's see, that's going to take us to, I got this right. Minus 2, 2, 3. Let's see. 4 is 20 over 10 is. So minus 14. This is going to be like a 3, roughly. So we have the point minus 3, 2.5, about here. Minus 2, 3, which will be right here. My graph is coming in like this. It's going to do something like this. And then it's going to go through there, right? Off a little bit, I think. And my inflection point is right around in there where my curve changes shape. Right? So we get a rough idea of what's going on with our graph. Right? And let's just do one more in terms of the whole test. And so if f of x is x cubed over 3, x squared minus 35x plus 12. So in terms of the first derivative test, we get f prime is going to be x squared plus 2x minus 35. Take that derivative, set it equal to 0. So this will give us x plus 7, x minus 5 equals 0. So that'll be 0 if either x plus 7 equals 0 or the x minus 5 equals 0. So this will give us x equals negative 7, and this will give us x equals 5. So we have our two numbers. So again, we build our chart for this. And so we're going to have on our chart negative 7 and 5. And the terms were x plus 7, x minus 5, and then our derivative. So if x is less than negative 7, this will be negative, this will be negative, and a negative times a negative is a positive. In between negative 7 and 5, x plus 7 is positive, x minus 5 is negative, and a positive times a negative is a negative. And then lastly, if x is greater than 5, then we're positive across the board. So again, this will be increasing, this is decreasing, this is increasing, this will be a max, and then this would be a min. Okay. So now we get to the second derivative test. And so we have that the first derivative was x squared plus 2x minus 35. So my second derivative is going to be 2x plus 2. Take that derivative, set it equal to 0. So 2x equals minus 2, so x equals minus 1. Again, we come up with a chart. Minus 1. We only have one term. And then my derivative. So if we're less than negative 2, this is negative, which means my derivative is negative. And if we're greater than negative 1, these will be positive. So this is concave down, this is concave up, and then this is NIP. Okay. And that will conclude this lesson.